all about investigating temperature changes in chemical reactions.
You need to know that every single chemical reaction involves some kind of change in energy.
So, at the very heart of this practical is this idea of energy transfer. Just think of it like this. Energy is either moving out of the reaction into its surroundings, or it's being pulled in from the surroundings. Now, this is where it gets really simple. All reactions fit into one of two boxes. You've got your exothermic reactions. These are the ones that transfer energy to the surroundings, which makes things heat up. A great way to remember this is exo sounds like exit, so energy is exiting. Then you have endothermic reactions. These do the opposite. They take energy in from the surroundings, making things feel colder. Think endo sounds a bit like enter, so energy is entering the reaction. And you know what? This stuff is happening all around us every single day. Think about the warmth coming off of a bonfire. That's exothermic. Or what about those instant cold packs you use for a sports injury? You snap it and it gets freezing cold. That's a perfect example of an endothermic reaction at work.
Okay, so we've got the theory down. Now let's get to the fun part, the how. This is what you're actually going to be doing in the lab.
Now, the equipment is pretty basic, but every single piece has a job to do. And here's a top tip for you. Examiners absolutely love to ask why you use a polystyrene cup. You need to have this phrase ready. It's an insulator and it reduces heat loss to the surroundings. That's a guaranteed mark right there. The actual procedure is a really straightforward 5-step process. Your main goal is just to measure the temperature at the start, and then the highest or lowest temperature it reaches at the end. Once you have those two numbers, you can work out the overall temperature change. And, in science, we like to use symbols. The symbol for change is the Greek letter delta, that little triangle. So you'll often see this written as delta T. How do we turn that data into an actual conclusion? Well, that temperature change you calculated, it tells you everything you need to know. Honestly, it's this simple. If the temperature went up, your reaction is exothermic. If the temperature dropped, it's endothermic. That's it. This table just shows you that direct link between what you see, the temperature change, and what's actually happening with the energy. A lot of the time, you'll be asked to plot your results, maybe on a bar chart like this one. You can see it really clearly here. The acid and metal reaction, boom, a positive temperature change of 15 degrees. That's exothermic. But look at the other one, the citric acid reaction. The temperature actually went down by 8 degrees. That negative change tells us it's endothermic. Okay, but let's be real, no experiment is ever perfect. So now we're going to look at how you can evaluate this practical and suggest ways to make it even better. By far, the number one enemy in this experiment is unwanted heat transfer. Think about it. You're trying to measure the heat change from the reaction, but what if some of that heat just escapes into the air in the classroom? Or what if heat from the room gets in? That's going to mess up your results for sure.
So the whole game is about one thing, minimizing that heat transfer as much as you possibly can.
And lucky for us, there are some really simple ways to do this. First, put a lid on the cup. Easy. Second, you can pop that cup inside a bigger beaker and stuff the gap with cotton wool for some extra insulation. And finally, the golden rule of science. Repeat it. Do the experiment at least 3 times and calculate an average, making sure to ignore any weird anomalous results. All of these steps will make your results so much more accurate and reliable. All right, let's bring this all together and look at how this stuff actually comes up in an exam. Okay, here's a classic 2-marker. They'll give you a scenario like a student mixing an acid and alkali and seeing the temperature go up, and then they'll ask you to explain what's going on. Now, to get full marks here, you have to do 2 things. First, for 1 mark, you just state the type of reaction. In this case, because the temperature went up, it's exothermic. But for that crucial 2nd mark, you have to explain why. You need to say that it's because energy is being transferred or released to the surroundings. You have to use that language of energy transfer. Here's another really common question type, and this one's all about checking if you know how to improve the method. Again, it's asking for 2 ways, so you need 2 separate points. Just say, use a lid on the polystyrene cup. That's 1 mark. Then say, place the cup in a beaker with cotton wool. That's your 2nd mark. These are really easy marks to pick up if you just remember those simple improvements we talked about. So let's just do a super quick recap of the absolute essentials. 1, exo means temperature goes up. Endo means temperature goes down. 2, you've got to use a polystyrene cup and a lid to insulate it properly. And 3, for accurate, reliable results, you repeat the experiment and find the average. Nail those 3 points and you're golden.
And that's pretty much everything you need for this required practical. The big idea here is that by carefully measuring something as simple as temperature, we can actually unlock the secrets of how energy moves around in chemical reactions. So, now that you're an expert, have a think. Where else do you see these exothermic and endothermic reactions happening in your own life?